Hello all, welcome to the video lecture. In this video, we'll be discussing about the diagnostic analytics and different techniques associated with it. Well, in our last video, we discussed about the descriptive statistics, which included measure of central tendency, including mean, median, mode, and measure of dispersion and probability distribution. While talking about the descriptive analytics, this descriptive analytics describes or summarize the raw data and make it something that is interpretable for by human. Basically, it answers the question, what happened? So, in our last videos, we try to find out like the answer, what happened, and once the data is described, the next step is to seek the independent variable affecting the target or dependent variable through answering the question, why did it happen? So we will try to find out the answer, why did it happen. So the diagnostic analytics focuses on the different reason behind the observed patterns that are derived from the descriptive analytics. So while going through the so we will go through the inferential statistics, and it consists of statistical methods that are used to test hypotheses that relate to the relationships between the variable. So for example, we might hypothesize that the individuals with the greater level of education tend to find the higher incomes. So we use some kind of inferential statistics to demonstrate whether or not there is a relationship between the variables. With all inferential statistics, the selection of the test or the selection of hypothesis test will depend on the nature of data available as well as the nature of hypothesis, like and we will also be discussing about, and here we will be discussing about the Pearson correlation coefficient, the z-test, t-test, chi-square test, and the ANOVA or analysis of variance. So the Pearson correlation coefficient basically is used to demonstrate whether the two variables are correlated or related to each other. When we are using the Pearson's correlation, the two variables in the question must be continuous, or it should not be categorical. So it can be used, for example, to test the relationship between the year of education and the income. As two variables are both continuous variables, but not the race and the height or the highest degree or the race and the highest degree completed. Similarly, the chi-square test is used whether or not there is a relationship between the categorical variables. For example, we can use chi-square statistics to show the relationship between the highest degree completed, for example, like the coded as a high school diploma or bachelor's, and the political affiliation coded as a Republican or Democrat. So this chi-square statistics is used to show the relationship between the two categorical variables. Similarly, the t-test is used to test whether there is a difference between the two groups on a continuous dependent variable. And so, for example, we would select the t-test when testing whether there is a difference in income between the male and the females. And similarly, ANOVA or the analysis of variance is very similar to t-test, but it is used to test the differences between the three or more groups. For example, we would use ANOVA to test whether there is a difference between income between black, whites, and Hispanics, or the ANOVA is actually a generalized form of the t-test, and when we conduct when conducting the comparison on the two groups, the ANOVA will give identical results to the t-test. So it is just the generalization of the t-test. So let's discuss in more detail about the Pearson correlation. Basically, the purpose of correlation coefficient is to determine whether there is a significant relationship or the correlation between the two variables or not. So the most widely used correlation coefficient is the Karl-Pearson correlation, and it was proposed in 1985 and is commonly known as the Pearson correlation coefficient, and it is used to illustrate the relationship between the two continuous variables, such as, like as I stated, as I described before, like the years of education completed and the income. So the correlation between any two variables using Pearson correlations R will be in between -1 and +1, and the correlation coefficient means that there is the correlation coefficient of 0 means there is no relationship, either positive or negative, between these two variables. We'll see in example, like correlation coefficient of +1 means that there is a perfect positive correlations or relationship between two variables. Like in case of +1, as one variable increases, the second variable increases in exactly the same level or the proportion. Similarly, as one variable decreases, the variable would decrease in exactly the same level or the proportion when the correlation coefficient is +1. And when the correlation coefficient is -1, this means that there is a perfect negative correlation or the relationship between the two variables. Like in this case, as one variable increases, the second variable decreases in exactly the same level or the proportion, and also one variable decreases, the other would increase in exactly the same level or the proportion. So it's about the like the Pearson correlation coefficient when it's perfect positive or perfect negative, and when there is no correlation. So let's see a simple example. Here is our two variables. Like we can see here, the variable x, which is years of education, and another variable that is the income in thousands, or income variable, which is denoted by y. So the equation for Pearson's R is given in this equation. Like this is the directly simplified version of the Pearson's correlation, and basically in most of the cases in general, it is derived from the covariance between two variables, but this one is the simplified version of this standard Pearson correlation formula. Here what we can see here, like this request, you can see this equation requires, first we need to calculate the sum of product of data pair, and then mean and square. Then what we estimate is the sum of squares of both variables. So like for this example, what we do is, first we estimate the we sum of products of two variables. Like here we estimate the sum of product, and then we estimate the mean of y, or the average of y variable, and then x variable, the mean of x variable, and then we estimate the sum of the squared of the both variables x square, the sum of x square and sum of y square, and then here we have got the n, the number of cases or the data pairs, which is 10. And now we just plug these values into our equations, and here we can see this is our formula for the Pearson correlation. And once we plug this value, we get the correlation coefficient, which is 0.9743. Now this is just a simple example of Pearson correlations, and we can see here the value of this coefficient is positive and it is more close to 1. So based on this correlation coefficient, we can say that it is positively correlated. And as I described before, like when it is positively correlated, then if we increase the x value, then y will also be increased, and as we decrease the y x, then y will also be decreased in the same proportion. So it's all about the correlation coefficient, but we still need to calculate the p-value in order to determine whether this correlation is statistically significant or not. This means that once we calculate the once we calculate this correlation value, basically this tells us about the strength of strength of linear relationship between the two variables x and y. Like here in our case x and y, this coefficient will tell us about the simply tell us about the relationship between two variables. However, the reliability of the linear model also depends on the how many observed data points are in the sample. So we need to look at the both the value of correlation coefficient, this r, and also the number of size, this n. We have got this n together, and we perform the hypothesis test of the significance of the correlation coefficient to decide whether this relationship in the sample of data is strong enough to be to use to the model the relationship in the population. So for this we need to go for the hypothesis test, so that this model is this can be modeled for the like this is simply for the sample, and whether we can generalize it for the population or not. So for that we will go for the hypothesis test. So we will be discussing about hypothesis test in more detail in our next video.